Welcome to the last video of the section, Estimating Housing Prices. Previously, we built a single and multivariable regressor. In this video, we will estimate housing prices using a support vector regressor. We will use the SVM concept to build the regressor. We will use the dataset available in sklearn, where each data point is defined by 13 attributes. Our goal is to estimate the housing prices based on these attributes. Create a new Python file and import the necessary packages. Load the housing dataset. And shuffle the data so that we don't bias our analysis. Split the dataset into training and testing in an 80/20 format. Create and train the support vector regressor using a linear kernel. The C parameter represents the penalty for training error. If you increase the value of C, the model will fine-tune it more to fit the training data, but this might lead to overfitting and cause it to lose its generality. The epsilon parameter specifies a threshold. There is no penalty for training error if the predicted value is within this distance from the actual value. Here, we train the support vector regressor. Evaluate the performance of the regressor and print the metrics using this command. Let's take a test data point and perform prediction. Let's run the code and see the output. With this, we reach the end of this section. In this section, we learned the difference between supervised and unsupervised learning. We discussed the data classification problem and how to solve it. We understood how to pre-process data using various methods. We also learned about label encoding and how to build a label encoder. We discussed logistic regression and built a logistic regression classifier. We understood what naive Bayes classifier is and learned how to build it. We also learned how to build a confusion matrix. We discussed support vector machines and understood how to build a classifier based on that. We learned about regression and understood how to use linear and polynomial regression for single and multivariable data. We then use support vector regressor to estimate the housing prices using input attributes. In the next section, we will learn about predictive analytics and how to build a predictive engine using ensemble learning.